Assalamualaikum warahmatullahi wabarakatuh. My name is Intan Sofiana and we are from group number 7. We are going to presenting chapter 6 programming. So solving problems using a computer. Solving problems is methodologies for creating computer programs that perform a desired function that the user needed. So problem solving is actually how do we figure out what to tell the computer to do. So we need to convert the problem statement into algorithm using stepwise refinement and convert algorithm into LC3 machine instruction. Next is debugging. So what is debugging? Debugging is how do we figure out why it didn't work by examining registers and memory, setting breakpoints, etc. Next, stepwise refinement, also known as systematic decomposition. It starts with a problem statement, as example given in the slide. We wish to count the number of occurrences of a character in the file. The character in question is to be input from the keyboard and the result is to be displayed on the monitor. Decompose tasks into a few simpler subtasks. Decompose each subtask into smaller subtasks and this into even smaller subtasks, etc. until you get to the machine instruction level, which is the lowest level in programming. Next, problem statement. Because problem statements are written in English, they are sometimes ambiguous and or incomplete. As examples, number 1, where is file located? How big is it? Or how do I know when I've reached the end? Example number 2, how should we final count be printed? A decimal number? And the last one is, if the character is a letter, should I count both uppercase and lowercase occurrences? So, how do you resolve these issues? The first one, we can ask the person who wants the problem solved, or us as a programmer can make a decision and document it to the client. So three basic constructs. There are three basic ways to decompose a task, which are sequential, conditional, and iterative. Sequential is we solving the subtask step by step. Okay. While conditional usually involve in selection, if else, and so on. And the last one, iterative, usually involve while loop. Okay. So sequential is do subtask 1 to completion, then do subtask 2 to completion, etc. As the main problem statement given, it states that we need to count and print the occurrences of a character in a file. So from this main problem statement, we can simplify it into three subtasks. Okay, into three simpler subtasks. As number 1, as the subtask number 1, get character input from keyboard. And the next one, subtask number 2, examine file and count the number of characters that match. And the last one is print number to the screen. So the computer will read and run these three subtasks in sequential. And these three processes will execute the same output of the main problem statement. So next, I pass it to my group mate to continue the next slides.
The next slide is conditional. If condition is true, do subtask 1 as do subtask 2. In the slide, we can see the explanation. Test character if mass increment counter count equal count 1 count equal count plus 1. We can see file char equal input. File char equal input also have true and false. The next is iterative. Do subtasks over and over. That means as long as the test condition is true. So the program can do the next process. Check is element of the file and count the character that match. More char to check. Also have false and true. If true, the programming is do. The next process is check char and count if match. The next slide is problem solving skill. Learn to convert problem statement into step-by-step description of subtasks. The problem solving is how we learn to convert the problem statement with step-by-step. The example is like a puzzle or a word problem from grammar school math. What is the starting state of the system? What is the desired ending state? How do we move from one state to another? Recognize English words that correlate to three basic constructs. Do A then do B equal sequential. If G then do H is equal conditional. For each S do Y if interactive. Do Z until W is interactive. LC3 Control instruction. That means how do we use LC3 instruction to encode the three basic constructs. The LC3 have two. First, sequential. Instruct naturally flow from one to the next. So no special instruction needed to go from one sequential subtask to the next. Second is conditional and iterative. Create code that convert condition into N, Z or P. Example, condition is R0 equal R1. Code subtract R1 from R0. If equal Z bit will be set. Then use BR instruction to transfer control to the proper subtask. The next slide is code for conditional. We can see the process in the slide start from test condition, have true and false, and have subtask 1, subtask 2, and the next is next subtask. We also can see in the instruction. Next is code for instruction. In the code for instruction have test condition, subtest, also have true and false, and next subtest. In instruction generate have A, B, and C. A is generate condition, B is subtest, C and next subtest. For the question symbol, exit bit depend on condition being test. For C, that means PC offset to address C. And in the subtest, we can see the number 111 is unconditioned breach to retest condition. And A is PC offset to address A.
Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Okay, I am the next presenter and my name is Nurazi Izwan bin Abdullah with a matrix number D2020 1095597. Okay, today I'm going to represent for the next slide. Is about counting character example. Okay, for this character we can see that based on this character, in order to execute a few tasks based on the problem statement, firstly we have to know what is the type of the problem. Based on this example, counting character, it showed that a flowchart that started with a start and end up with stop. Okay, the both between it is a big task also had been delegated into a few subtasks. We really need a few solution based on sequential construct. Okay, for example, based on this flowchart, it is start with start and then input a character, then scan a file counting occurrence of that character. Finally, display on the monitor the number of occurrences of the character up to 9, and next is stop. Okay, in order to accomplish this big task, sequential construct will be used. For example, it will be delegated into a 3 subtasks, which have a subtask A, subtask B, and subtask C. Okay, for subtask A, we will put initial value for all locations that will be needed to carry out this task, such as input a character, set up a pointer to the first location of the file that will be scanned, get the first character from the file, 0 the register that hold the count. For the subtask B, will be scan the file location by location and increment the counter if the character match. For the subtask C, this is the final task. Where we will display the count of the monitor, and finally stop. That is the ending of the subtask for this sequential construct. Okay, next is refining B. Okay, refining B, which also based on my understanding, refining B is also known as the process of the subtask B. Based on this slide, we can see that for the refining B, this really involve of the iterative construct process. Okay, for this B, we will go to the next stage, which we will scan the file location by location, incrementing the counter if the character if match. In this subtask, we can go more deeply based on this example. The right example, we can see that this really need a few process such as iterative construct, will also known as the loop. For the loop process, for example, I giving to you. Okay, for the loop process, as we can see, the task will continue doing the same action until at the end it will be automatically stopped based on the question of the problem statement requested. For example, if the question asks the range of the number between 1 until 9, so at the end of the process, during this process, the machine will print out number 1, number 2, number 3, 4, 5, 6, 7, 8 until number 9, and at the end of the number 10 it will be automatically stopped. This is based on the iterative construct law or the iterative construct process. or law or principle. Okay. Okay, next slide. Next slide, we go to the refining B1. Okay. For the refining B1, this we can see that after the iterative process, next process is sequential process, which this B1 will go to next stage, such as this B2, test character, if match, increment counter. Okay, the next, get the next character is, as we can see, these sequential subtasks also looks like our daily life routine, such as when we wake up at the morning, we will usually brush our teeth. At the afternoon, we will have a lunch, and at night, we have a dinner. This is usually equal to this process, sequential process subtask for refining B1. Okay. For the next stage, refining B2 and B3. Okay, for this stage, the B2, the refining B2, for this test character if match increment counter, it will be go to another next process, which mean it will use a conditional process or selection construct where we need to where the process really need to choose other two tasks, which mean in this process there will have two subtasks will be chosen based on the state, true or false. Okay, let's see for this B2 refining. Okay, from the process we can look that we can see the flow chart that look like a diamond. R1 equal to RO. If is it true, then if is it yes, then R2 equal to R2 plus 1, then you will choose that task. If it is not or false, then it will also continue the next process. Okay, for the B3, get next character. Okay, B3, we can see that from this B3, it really needs the sequential construct, which it start from the R3 equal to R3 plus 1, and the next is R1 equal to M R3. Okay, that is for this slide. For this slide, finding B2 and B3. Okay, for the next slide is about the last step, LC3 instruction. Okay, what does it mean? What's the LC3 instruction? LC3 instruction, when we come to this stage, we will use a command to separate into modulus and to document your codes. For example, based on this flow chart it start with the sorry for this. Okay, for debugging. Okay, what does it mean about debugging? Okay, debugging is the process when we return our program that it doesn't work. For example, when we coding something, suddenly it occurs syntax error, or the time then we will need to redo it again, or trace where is the lack of the programming or the lack of the coding that will need to be improved. That is the process we call as a debugging, which means we want to ensure that the program is works efficiently and fastly based on user need. Okay, what do you do when you lost in a city? Drive around randomly and hope you find it, or return to unknown point and look at the map. Okay, this is a few example for the debugging process. Okay, based on this debugging process, we can see that if we lost in city, of course, I will return to the norm point and look at the map. This also same as a coding process, because in debugging, the equivalent to looking at map is tracing your program. Why I say that? In order us to know our true way or our true destination, we have to look back to our previous point and to the map. This based on this example lah. Okay. Exam description of discussion being executed. Keep trace result. Okay. Okay. Next, I will pass this explanation for this chapter 6 to the next presenter. Okay. Thank you.
This is debugging operation. Any debugging environment should provide means to 1. Display value in memory and register. Number 2. Deposit value in memory and register. Number 3. Execute instruction sequence in a program. Number 4. Stop execution when desired. Different programming levels offer different tools. High-level language, C, Java, usually have source code debugging tools. Next, for debugging at the machine instruction level, number 1, simulators. Number 2, operating system monitor tools. Number 3, circuit emulator ICE, plug-in environment, plug-in hardware replacement that give instruction level control. This is LC3 simulator. The green color show the execute instruction sequence. The red color show the stop execution or set breakpoint. And the blue color show the set display, registers, and memory. Types of errors. Syntax error. You made a typing error that results in an illegal operation. Not usually an issue with machine language, because almost any bit pattern corresponds to some legal instruction. In high-level language, these are often caught during the translation from language to machine code. Logic errors. Your program is legal but wrong, so the result don't match the problem statement. Trace the program to see that really happening and determine how to get the proper behavior. Data errors. Input data is different than what you expect. Test the program with a wide variety of inputs. Tracing the program. Execute the program one piece at a time. Examining register and memory to see result at each step. Single-stepping. Execute one instruction at a time. Tedious but useful to help you verify each step of your program. Breakpoints. Tell the simulator to stop executing when it reaches a specific instruction. Check overall result at specific points in the program. Let you quickly execute sequence to get a high-level overview of a execution behavior. Quickly execute sequence that you believe are correct. Watch points. Tell the simulator to stop when a register or memory location changes or when it equals a specific value. useful when you don't know where or when a value is changed. This is example 1 multiply. This program is supposed to multiply the two unsigned integers in R4 and R5. This is debugging the multiply program. The blue color should stop looping here. The red color shows the single stepping and breaking point at branch X3203. Executing loop one time too many branch at X3203 should be based on Z bit only, not Z and P.
Slide show example to summing an array of numbers. This program is supposed to sum the numbers stored in 10 locations beginning with X3100, leaving the result in R1. This slide provides some very useful hints and it shows the address and contents of that address. The program in example 2 starts with when run with the array of data also given yield or end with our one holding x0024. However, the sum in our one should be x8135. This slide shows example 3 looking for a 5. This program is supposed to set R0 equal 1 if there's a 5 in 110 memory locations starting at X3100, else it should set R0 to 0. This slide provides some useful hint that shows the address and contents. This program start or run with a 5 in location X3108 and our result in R0 equals 0 and not R0 equals 1. This slide shows the example for finding first one in a word. This program is supposed to return in R1 the bit position of the first one in a word. The address of the word is in location X3009. Just past the end of the program. If there are no one, R1 should be set to -1. This slide shows debugging the first one program. The program works most of the time, but if data is 0, it never seems to help. If no one, then branch to help never occurs. This is called an infinite loop. Must change algorithm to either A. Check for special case R2 equals 0 or B. Exit loop if R1 smaller than 0. The summary of our presentation on debugging, we learned some lessons that you have to trace a program to see what's actually happening within the programs, and in order to do that, you're going to need to set breakpoints and use single-stepping mode. After the breakpoints, the programs will going to write, analyze, decompose. They're going to be too long to single step through the entire program, and they may have iterative structures, construct with intent that call for 10, 20, 100, 1,000 iterations, so single stepping is not a viable solution to debug. A programmer should be the only tool in your toolbox for debugging this program. So when tracing, make sure to notice or actually verify what's happening, not what you think is happening. So in summing program will be easy to not notice the address X3107 was loaded instead of X3100 being tested program using a variety of input data. As we get into input output will be able to solicit data from the user, and we won't have to artificially place data in an array. You also must test your program using a variety of input data. In example 3 and 4, the program work for many datasets. Be sure to test extreme case with all one and no ones.